Welcome everybody. Last slot of the day. You could be out in the city drinking beers, but you're here with me, so thank you for that. I'm honored. My name is Bouke Nijhuis. I'm the CTO at a company called Sync ICT, and you can easily reach me on Twitter on the handle that's currently on screen. The topic of today is improving your skills with the debugger. There are 4 topics I would like to talk about today, and the first one is breakpoints. I assume everybody knows that a breakpoint pauses the execution of your program. But you can do more with breakpoints, and I'm going to show you what's more. The second topic will be evaluating expressions. So while debugging, I see the variables and their values, but I would like to go one step further. I would like to see the outcome of expressions. The third topic will be hot code swapping. I will be changing code in a running program without restarting it. And the last topic will be remote debugging. So normally when you're debugging the program that is started by your IDE, but it doesn't have to be the case. It can also be started elsewhere. I'm not only going to talk about those topics, I'm also going to show them to you. This is a live coding session, and therefore I need some code to show off those 4 topics. So I created a little program called Hello World. Maybe you heard of it before? Okay, just to be sure, I'm going to demo it to you. If I run it, it prints Hello World to the console, like a proper Hello World program should. But I also added a little twist. If you provide an argument, in this case my first name, Bouke, it will print Hello Bouke. So those are the 2 features of this fantastic program. Thank you, thank you. Yeah. I think I do deserve that, yeah. So let's look how that looks in the code. Quick overview. There's a Hello World class, which contains one field called default value, which contains the string world. Then there is the main method, the entry point of our application. And the first thing it does, it calls the method called createMessage, and it passes the command line arguments. So that method is over here, and it contains one variable called name, which defaults to the default value world. Then we check if there's any input argument, and if that is the case, we update the value of the name variable. Lastly, we use a string.format to create the string that starts with hello and then the value of the name variable. The string is returned to the main method, and then the last thing we do, we print this string to the console, like I've just demoed in the terminal. So no rocket science here, but I don't need rocket science to show off those 4 topics. One more last thing before we dive into the first topic, and it is how do you actually debug in IntelliJ? Now that is pretty simple. You click somewhere in the gutter, that's the area next to the line numbers. Then this nice red dot pops up, this is a breakpoint. And then we go to the green triangle and we select the second option. If you do that, IntelliJ compiles your code, starts up your program, starts up the debugger and attaches the debugger. More about that later. So this is how it looks. The top part of the screen is still the same as before. We still see code, but now there's a big blue bar. This big blue bar is the current execution point. This is where your execution of your program is paused. In the bottom part, you see the debug tool window. On the left, you see the stack trace, and on the right, you see the variables and their values. So let's dive into the first topic, breakpoints. During the introduction, I told you I assume everybody knows that a breakpoint pauses the execution of your program. Now I'm sure because I just demoed it. I also told you I'm going to show you what's more. So let's find more. First thing I'm going to do, I'm going to right-click on the breakpoint. And if you do that, you get a nice pop-up. And hey, look at that. There is more. So if I click that one, I get an even bigger pop-up with a lot of options. Unfortunately, I only have 30 minutes, so I cannot talk about all those options here. I'm only going to talk about a small part of the screen. But before I'm going to do that, I would like to share something with you. Because I have a reflex. One of the first things I do whenever I start investigating a bug, I start with putting print lines in the code. And I do this for 2 reasons. First of all, I want to know which parts of the code are being executed. And secondly, I want to know the outcome. I want to know the value of variables. And I think I'm not the only one. So with a quick raise of hands, who also starts out with putting print lines in their code? I think about 30% of the people. It's nice to know I'm not the only one out there. I think this is a fine reflex, but there is one big disadvantage. Sometimes, only sometimes, I forget to remove them. So are there other people in the room who have the same failing? Or so again, quick raise of hands. Less hands. Okay, there are people out there who do not forget to remove them. Pretty impressive. Wouldn't it be nice if there was a better way? And as it turns out, there is a better way. Let me show it to you. The better way is using this little function over here, evaluate and log. What I normally put in my print line, I nowadays put over here. So what I say, normally I do things like this. I want to know the value of the name variable. Does that look recognizable? And before I'm going to press the done down here, let's talk a little bit about this one. Suspend. By default, a breakpoint suspends or pauses the execution of your program, and that's exactly what you want. But in this case, I'm trying to emulate a print line. I just want to log something to the console and continue. So I don't want this breakpoint to suspend, so I'm going to uncheck this box. Now I'm going to press done. If you do that, the first thing that you notice is that the red circle became a yellow circle. Yellow means it will not suspend or pause the execution of your program. Let's run to see what will happen. I started the debugger, and as you can see, it printed hello world, as we expected. But there is also something new here. This is a new log line. So what I've just shown you is an alternative to using print lines. Why don't I prefer using print lines? Because in the best case, they end up in a PR, and then my colleague says, come on, Bouke, step up your game, you should do better. In the worst case, they end up in production. Still, I don't think this is really bad. The chances are really small that it will break your program or that it will log something sensitive, but it is kind of unprofessional. By using this way, it will never end up in a PR, because a breakpoint is not code. It will never end up in production, because a breakpoint is not code. Therefore, I would say use this method. Now I hear people thinking, but Bouke, this is really nice and dandy, but it's a lot of steps to get this, right? First I have to create a breakpoint, then I have to right-click, then I have to click the more link, and then I have to do even more stuff. You're totally right. Let's see if we can improve this workflow. So if I hold the shift and click indicator, I directly get a breakpoint that does not suspend. So that saves you a lot of clicks. So I would advise in the future, don't use print lines, use logging with breakpoints. And that brings me to my next topic, which is evaluating expressions. There are several ways of evaluating expressions in IntelliJ, and I would like to start with the first one, quick evaluate expression. The quickest way I know to evaluate an expression. Let me create a proper breakpoint. Let me restart the debugger. So the expression that I would like to evaluate is this one. And if you want to use quick evaluate expression, you hold the Option key if you're on a Mac. If you're on a Windows on a Linux machine, you hold the Alt key. And then you hover over the expression that you would like to evaluate. It becomes underlined, and then you left click. And then you get this little pop-up, which doesn't work properly in presentation mode. So let me enlarge it for you. So with just one click, I evaluate an expression. And this is quick evaluate expression. The name, quick evaluate expression, implies that there is also a normal evaluate expression. Let me show you that one. So to use that one, I select the thing that I would like to evaluate, and then I press this nice little button down here, or I press the appropriate shortcut key. And if you do that, you get a big pop-up with the expression pre-filled. This is because I selected the expression before I clicked the button. Now I press enter, and it will evaluate the expression for me. This is a bit slower because I have to do more clicks, but this one has a big advantage because now I can play with the expression. Let me show it to you. I change the name into a string containing my name. I press enter, and it re-evaluates the expression. Instead of hello world, it now says hello Bouke. And this is really useful whenever you know the location of your bug, but you don't know exactly how to fix it. Let me give you an example. So let's say I don't want to print a string, but I want to print hello space 1.00, exactly 2 zeros, and then an exclamation mark. Let's try if this works. Almost there, 1 0. I want 2 zeros. So I'm a developer, so I'm lazy, I don't read documentation. I'm just gonna try, I'm gonna play with expression, right? Most people would do that, at least. I hope so, I think so. So I know this S is for string. There's a decimal there, so let's try D. Illegal format conversion exception. Too bad. Maybe it's N from number. The exception went away, but still not the desired outcome. I can try I from integer. It's not an integer, but let's try anyway. Again, an exception. Oh, wait. Now I remember. I think you have to give an example in the proper format, and then the string.format will make the string in the correct format. Again, exception. Oh, now I remember. I have to add an F. Hey, you see? Also, the background color became white again. Probably I'm right. Whew, almost there. I see 11 zeros. But now I know what to do. And this is the desired outcome. Did you see what just happened? I tried about 6 fixes in under a minute. And this is the power of evaluate expression. So whenever you want to try out a lot of fixes in a short amount of time, use evaluate expression. Also a word of warning. While playing with expressions, you could be changing the global state of your program. Let me give you an example. If you do something like this, I've changed the value of the name variable. Now I close this pop-up. I finish the execution of the program. And it says, hello Fritz. There's no Fritz in the code. There was no Fritz in the arguments. Because I played around with evaluate expression, I changed the global state of my program, and therefore the outcome of my program. So please be aware if you play around with evaluate expression. So the last thing within this chapter is I would like to evaluate a very special expression, namely a stream. I prepared a little stream, and I'm going to do 2 things. First, I'm going to try to explain the stream with words, and secondly, I'm going to show you how you can see how the values stream to the stream. That's not a nice sentence, but please bear with me. First off, let's try to explain what it does. It's a simple right-shifting algorithm. That means that it takes every character in a string and then moves them one up. So an A becomes a B. So if the input is ABC, the output would be BCD. Okay, how does that work in the stream? I start with the name variable, which is string, and then I apply the gars operation. This converts every character in a string into an ASCII code and delivers me a stream of ints, an int stream. Then I increase all ASCII codes by 1. Then I transform all increased ASCII codes into strings, into single character strings. And lastly, I join all the small strings into one big string again. This is just an example of a stream. It doesn't do anything useful. Explaining this wasn't really hard, but also not really simple. Wouldn't it be nice if we could get some more insight, if we could visualize this, if we could see the value streaming through the stream? And you can't get this insight with conventional debugging methods. It just doesn't work. But luckily there's a solution, and let me show you this solution. I'm going to restart the debugger. Whenever the debugger pauses on a line that contains a stream, this little button over here becomes available. There's 4 words there, but I prefer to call it a stream debugger, short and powerful. And if you click it, you get a pop-up, and it contains 4 tabs corresponding to the 4 operations in the stream. And remember, the first operation was taking every character in the string and transforming it into an ASCII code. And look at that, 5 ASCII codes. Then the next operation was increasing all the ASCII codes by 1. On the right, all the numbers are 1 higher than on the left. The third operation was transforming the increased ASCII codes back into single character strings. On the left, ASCII codes. On the right, single character strings. And the last one was joining all the small strings into one big string again. So on the left, small strings. On the right, one big string. One unpronounceable word. So this stream debugger really gave me insight in what was happening inside the stream. So the next time when you have to debug a stream, use this fantastic tool. It will save you a lot of time. And that's everything I wanted to tell you about evaluating expressions. Let me clean up a little bit. And let's continue with the next topic. The next topic is... I don't remember, but lucky I have this one. Hot code swapping. But before I'm going to talk about hot code swapping, I first would like to talk about something else. So whenever you are debugging and you are stepping through your code, you have the starting point of your application and you have the termination point of your application. And then you have the stepping operations like step over, step into, step out, run to cursor. All those operations are going forwards in time. And what I would like to do, I want to time travel. I want to go backwards in time. And as it turns out, there is an operation for that. And that operation is called drop frames or reset frames. So the next logical question would be, what is a frame? Very good question. To explain that, we first have to talk about stack traces. I assume everybody knows that stack traces are built up out of method calls. So it starts with the main method, calls another method, calls another method, calls another method. So we get a stack of method calls, like you see in the bottom left of the screen. Currently, there are 2 items in the stack trace. Another word for an item in a stack trace is a frame. So if you drop a frame, you remove something from the stack trace. It's a stack trace, so you can only remove from the top. Currently, the debugger is not running, so let me start the debugger. Currently, the execution is paused on line 14. And as you can see in the stack trace, it also says colon 14 over here, it is in a create message method. So if I drop a frame, this is the button over here. Nowadays it's called a reset frame. In the past there was a button over here which said drop frame. That's why I use both words. But if I click on this button, it will remove the top item in my stack trace. And it will go back to the main method. Let me show you what happens. If you do that, you see the blue bar went from line 14 to line 8. Debugging-wise, we have been time traveling. We are going back in time because we are now in a point of time that we still have to call the create message, while a minute ago we were in the create message. This time traveling effect only works within the Java context. If you did a database transaction and you're dropping the frame, that database transaction will not be rolled back. But everything within the Java context will be rolled back. I use this dropping frames whenever I'm debugging somewhere near the termination point of my application. I find something interesting, but now I have to play somewhere at the beginning of the application. Of course, I can put a breakpoint over here, restart the application and start over. But I could also just drop a few frames to go back in time so I can play with the part that I'm really interested in. And dropping frames becomes even more useful if you combine it with hot code swapping. So let's talk about hot code swapping. Let's not talk about hot code swapping, let's just do it. What I'm going to do, I'm going to move the breakpoint over here. And did you see what I just did? I dragged and dropped a breakpoint. I didn't know that was possible until I started investigating for this presentation. Let me restart the debugger. The application is paused at line 8. So what I'm going to do, I'm going to change hello into bonjour, the French version of hello. And now I have to reload this class. The fastest way to do that is press Shift-Shift, which is search everywhere, the best invention since sliced bread in IntelliJ. And then I type in the first letters of reload changed classes, RCC. And if you do that, IntelliJ compiles the class, reloads the class, and then there will be a green balloon telling you that it's finished. Let us finish the execution of the program. And as you can see, it now says bonjour world, like it says in the code. So I changed the code without restarting it. When we started the program, it said hello world. I changed the code. I didn't restart it, but I used hot code swapping to change the code. I will explain you in a minute when this is useful, but first I would like to talk about the limitations. There are a few limitations to hot code swapping, but the most annoying one, in my opinion, is that you are not allowed to change code in your current method or frame. Let me show you what happens. I moved the breakpoint on purpose, because if I put it over here and I redo the little demo, now I'm going to change bonjour into Guten Tag, the German version of hello. I'm going to reload the change classes again. We wait for the green balloon. There's the green balloon. And now we finish the execution of the program. Hey, it still says bonjour. but the code says Guten Tag. So the hot code swapping failed. And that's because I changed code in my current method. Let me show you again. My current method is the create message. As you can see, it's the top item in the stack trace. So if you change something within that method, the hot code swapping will fail. Luckily, there's a workaround. And the workaround, of course, is resetting the frame. You see, now my current method is the create message. I changed something. I'm gonna change something. This should be hello. And I reload the change classes again. So now I change something in the create message method, but my current method is the main method. So I do not change something in my current method. If I now finish the execution of the program, it says, oh, I typed in hello. No, it doesn't matter. Also works for the demo. You see, I used dropping frames to work around the limitation that you are not allowed to change in your current method. So why do we need this workaround? Because many times when I'm debugging and I'm stepping through the code and I find the issue, I also need to fix the issue in that spot. This is not always the case, but in a lot of cases I need to fix something in exactly that spot. Therefore, this is really useful to be able to work around this limitation. So when do I use hot code swapping? I use hot code swapping whenever I have an issue that I cannot reproduce with a unit test. So in most cases, I have an issue. I write a unit test. I run the unit test. It's red because I didn't fix the issue. I fix the issue. I run the unit test again. And if it becomes green, in most cases, I have fixed the problem. But sometimes I have issues that I cannot reproduce locally, that I cannot reproduce with a unit test. And if that's the case, then it's really, if you don't apply the things I just talked about, what you do is you write a fix, you restart your application, you do some manual actions because there's no unit test to see if the problem is gone. If the problem is not gone, you start over, you write a fix again, restart the program and do manual interactions to see if it's gone. My proposal would be, instead of restarting, use hot code swapping. Instead of doing manual actions somewhere, you drop a frame. Both actions are faster. And as an added bonus, you can stay in your IDE. You don't have to leave your IDE. And it becomes even more useful if you combine it with remote debugging. So let's talk about remote debugging. During the introduction, I told you remote debugging. During the introduction, I told you that you normally debug a program that is started in your IDE, but it doesn't have to be the case. What I'm going to demo is I'm going to start a program in the terminal, and then I'm going to instruct the debugger in IntelliJ to debug the program running in a terminal. So during the beginning, I told you that IntelliJ compiles code, starts up a program, starts up the debugger, and attaches the debugger to the running program. So apparently there are two important parts. There's the running program and the debugger. If you look closely into the log, you can find traces of this. This line is from the debugger, and it tells that it's connected to the program that you want to debug. So apparently the debugger tries to connect to a program that is listening on a specific port. In this example, this port. So let me show you how we can instruct the debugger in IntelliJ. I'm going to press Shift, and then I'm going to go to Edit Configurations. The thing that we need is called the Remote JVM Debug Configuration. So if you type in remote, nothing happens. Demo effect. Oh yeah, of course, first I have to press the plus, or press Command N. And then if you type in remote, we find the thing that I'm looking for, Remote JVM Debug. I'm going to press Enter. And I'm going to give it a name that I recognize. So let's say it's DevOps Remote. Then there's some stuff over here, but the most important part is the host and the port. By default, a remote JVM debug configuration. By default, a debugger tries to connect to a program that is listening for the debugger on localhost 5005. That's a fine default. So how do I make my program listen for a debugger on port 5005? Actually, that part is pretty simple. You copy this, you go to the command line, and you insert it in the right spot, which is over here. Notice that I use double quotes because there is a star or asterisk in there, and shells tend to expand them, and then things will break. I don't want things to break while doing demos. So if I do this, hey, something new happened. You see this line? This is new. So apparently adding those command line arguments did something. Unfortunately, the program is so fast, it finished executing before I could attach a debugger to it. So I have to make one small change. Somewhere in here it says suspend is no. And if you say suspend is yes, the program starts up, starts waiting for a debugger, and pauses. So the program in the terminal is now waiting for a debugger to attach itself. Let's attach a debugger. We go back to IntelliJ. Everything in this screen is metadata. We didn't start up a debugger. This is just metadata to instruct the debugger. So I'm going to press OK. Again, I'm going to use Shift, and I'm going to type in, what was the name? Devox remote. So this one. And over here it says, press Enter for debugging. If I do that, hey, I see the debugger is attached to something, right? And that something has as input argument Bouke. Look over here, input argument Bouke. So the debugger in IntelliJ is now debugging the program in the terminal. And this is remote debugging. Now I hear people saying, yeah, that's all nice and dandy, Bouke, but you call this remote debugging. Where's the remote part? Everything is running on your Mac. Yeah, that's totally true. I run all the demos on my Mac because it's just easier. But if you want to do real remote debugging, which means debugging to a remote server, this is also possible. Let's go back to this screen. So now it says localhost 5005, but of course you can also put in a remote host or remote IP address in here. And if you do that, you can also debug stuff running on remote servers. Actually, there are two conditions for real remote debugging. The first one is your remote JVM should be open for remote debugging. Now that part is easy. You add those command line arguments like I just did in the terminal. And the second part is the debugger should be able to reach the JVM that you want to remote debug. Networking wise, it should be able to make a connection. There shouldn't be any variables in between. And if both conditions are true, then you can do remote debugging to a remote server. So when do I use remote debugging? I use it in two instances. The first one is whenever I have an issue that I cannot reproduce locally. So sometimes I have an issue that only occurs on a specific server or a specific instance. If that's the case, I cannot reproduce it locally, and then I use remote debugging to get more information. But it becomes really powerful whenever I want to try out a fix in a different server. If you don't use remote debugging in combination with hot code swapping, you have to create a fix, then you have to create a release, you have to deploy the release, and then you have to check if the thing is gone. But you, of course, can also use remote debugging to deploy your new code to the remote server, drop a frame, step a few frames forward, do a few steps forward to see if your problem is gone. And this approach is so much faster than creating releases and deploying releases. Also a word of warning, you could do this to your production server. I would advise not to because it's pretty dangerous. I just told you you can replace code. If you apply this technique with your production server, you could be changing production code without creating a release, so without an audit trail. So if you do that, please think twice. And that's actually everything I wanted to tell you. I hope everybody learned something new. If you have any questions, please come to me down here after the presentation. Thank you for being here and enjoy your evening, your beers and your food. Enjoy the conference. Bye-bye.